In this video we're going to be looking at elasticity of demand. So we've discussed that the quantity demanded varies inversely with price. When the price increases, the quantity demanded decreases. And when the price of a product decreases, the quantity demanded will increase. But how responsive is the change in demand to a change in price? That's what we're going to study. So will a small change in the price cause a big change in the quantity demanded, or only a small change? And there are three types of elasticity you need to be aware of. There's products with a high price elasticity of demand, products with unit price elasticity, and a low price elasticity of demand. We're going to go through each of these. So the PED is a critical formula you need to be aware of when you're looking at price elasticity. So price elasticity of demand is calculated as the percentage change in quantity demanded divided by the percentage change in price. So if a PED is less than 1, that means that demand is inelastic. And what that means is that a big change in the price, so a big change in the denominator, is only going to cause a small change in the quantity demanded. So the change in the denominator will be larger than the change in the numerator. If demand is unit elastic, it means that the percentage change in quantity is the same as the percentage change in price. And if a PED is more than 1, what that means is a small change in the price is going to have a big impact on the quantity demanded. So say a 1% change in price might cause a 10% decrease in the quantity demanded. It's an elastic demand curve. So a PED above 1 means a curve is elastic, below 1 means it is inelastic. So demand is relatively elastic. What that means is that, say for example, there was a 5% fall in price. That's going to cause a 20% increase in the quantity demanded. A small change in price has caused a big change in the quantity demanded. It could also mean a 5% rise in price causes a 20% decrease in the quantity demanded. That's what an elastic demand curve means. The change in price is smaller than the change in the quantity demanded. What we're going to look at now is how revenue is affected by an elastic demand curve. So here's an elastic demand curve. And why is it elastic? Well, let's have a look at that. So the old price we were charging, say, was $150. And at a price of $150, the quantity demanded was 600 units. Then we decided, all right, we're going to raise the price. We're going to raise the price by 200. So we've raised the price by about 25%. That's caused a massive change in the quantity demanded. It's actually led to a sixth of the quantity demanded. So now if we charge $200, we're only going to sell 100 units. So at a price of $150, we sold 600 units. At a price of $100, we're only selling... So at a price of $200, we're only selling 100 units. Okay, so a 50% price change has caused a decrease in the quantity demanded of 500 units. Just ignore that, that is just wrong. Okay, so a decrease in price of 50 units has caused an increase in demand of 500 units, or an increase in price of 50 units has caused a decrease in demand of 500 units. So let's look at the revenue that we would generate. So if we sold it at a price of $150, we would sell 600 units and generate revenue of $90,000. Okay, it's 150 times 600 units sold. If we sell at a price of $200, we're only going to sell 100 units, and we'd only be generating revenue of $20,000. So where are we going to generate more revenue? At the lower price. So to look at it here, if we decide to charge the higher price, we're going to lose all of this revenue in here. We're not going to sell this last 500 units, or these 500 units in here. So we're going to lose 500 times $150 of revenue, or $7,500 of revenue is going to go down the drain. 500 times 150, I hope that equals 7,500. But we will generate $50 times $100 more revenue, because the first 100 units that we sell, we're going to generate an extra $50 of revenue. So that's the revenue gained from selling the higher price, this yellow square. But the revenue loss is much higher. So we're much better off selling at the lower price. We're going to generate lots more revenue. Unit elastic, 10% change in price causes a 10% change in the quantity demanded. So basically the change in price is the same as the change in the quantity demanded. And the graph will look like this, or like this. And it really doesn't matter what price we charge in terms of the revenue, because if we're charging the lower price, say we're charging price X, the quantity demanded is going to be W, we're going to be generating all this revenue in here. If we raise the price to Y, we're going to sell much less units, we're only going to sell up to Z units, but we're going to generate a lot more profit per unit, a lot more revenue per unit. So it doesn't really matter what price we charge, we're going to be generating the same revenue. Then we've got the inelastic demand curve, and that means that a large change in price only causes a small change in the quantity demanded. So a 10% increase in price only reduces quantity demanded by 5%. Businesses want their curves to be as inelastic as possible because they want to be able to raise their prices to generate more revenue, and that have only a small effect on the quantity demanded. And that's why they try to establish brand loyalty. Businesses will advertise to try and get people to buy their products irrespective of the price. And that's why some companies can make lots and lots of money. So, for example, the iPhones, for example, have a relatively inelastic demand, and that's because a lot of them people see that they don't see any close substitutes to that product, even though there are substitutes. iPhones have a relatively inelastic demand because they're sort of a niche market. So let's have a look at how an inelastic demand curve will affect revenue when we increase the price. So here's an inelastic demand curve. And what I mean by that is, say initially we're charging the price of $50. The quantity demanded is 60. If we times that by 5 and start charging a price of $250, the quantity demanded is going to fall, but only to 40. Okay, so the quantity demanded has only changed by 20 units, and the price is now 5 times as high. So what was our old revenue? Well, we were selling 60 units at a price of $50, so our old revenue was about $3,000. Now what's our new revenue? Well, now we're selling only 40 units, but we're selling them at a price of $250. So our revenue is now $10,000, 40 times 250. So the old revenue was $3,000, the new revenue is $10,000. If we look at this graph in here, the old revenue is this amount in here. Okay, so the amount, by starting to charge the higher price, so from going from $50 to $250, we lose this revenue in here because we're not selling the last 20 units. But we gain all of this revenue in here that's the increase in revenue because we're selling it for $200 dearer for the first 40 units. So we're gaining 200 times, I'll just get my little pointer out, we're gaining 200 times 40 units of revenue, okay, and we're only losing 20 times 50 units of revenue. Very hard to draw. So the revenue that we gain, this amount here, is much higher than the revenue that we lose, this amount in here. And therefore we're better off charging a higher price. And that's why businesses want an inelastic demand curve. So to sum up, elastic goods, percentage change in demand is greater than percentage change in price. They're highly responsive to price changes, and increases in prices will lead to a fall in total revenue. Inelastic goods, percentage change in demand is less than percentage change in price. They're highly responsive to price changes. That says slightly. They're slightly responsive to price changes. They are still responsive, but not very responsive. And an increase in price will lead to a higher total revenue, a rise in total revenue, not a raise. Thank you.